3.2 Polynomial Division and the Remainder Theorem. Remember long division? We could do that with numbers, and now we are going to learn how to divide polynomials in a similar manner. So if we had 1,177 divided by 12, we would look at the first digit and say, how many times does 12 fit into 1? And it doesn't, so then we include the next digit and repeat the process. How many times does 12 fit into 11? Doesn't do that either, so then we include the next digit and say, how many times does 12 fit into 117? And it does that 9 times, so we put a 9 here. We're going to multiply 9 times 12 to see how much of this number we have taken care of with this 9 in the tens position here. So 9 times 2 is 18, so we put 8 here, put the 1 there. 9 times 1 plus 1 is 10. So we write that there, and we're going to subtract because we have taken care of 108 tens here with this 9. So we don't need to worry about that. So 117 minus 108 is 9. And then we bring down the last digit here, the 7. And we say, how many times does 12 fit into 97? And that would be 8 times. So we put an 8 there. Then we do 8 times 12, and that is 96. And we subtract that, and we find that our remainder is 1. Now, probably you learned to put a decimal place here and add some zeros and bring those zeros down and keep going. But in this case, and with polynomials, we're just going to work with this remainder here. Now, we can actually write down what we've done here. So 1,177 divided by 12. And that equals 98. And the remainder over the divisor. So 98 and 1/12. So there was just a remainder of 1 that didn't divide evenly here. We're going to do the same thing with polynomials here. Now we always want to get rid of the first term. So we're asking ourselves, what times x gives me x squared? And that would be x. So we're going to put an x here. And we're going to multiply x by both terms in this binomial. So x times x is x squared. And x times 3 is 3x. And just like when we were doing this with numbers, we are subtracting this off so we can see how much of this polynomial we have taken care of with this x right here. So x squared minus x squared is 0, so we don't need anything there. And we have 9x minus 3x, and that is 6x. And also, just like before, we bring down the 18 here. So we've got 6x plus 18. And we repeat the process. So up here, we're going to say, what times x gives me 6x? Looking for this times this to get rid of the first term here. So that would be 6. So 6 times x is 6x. 6 times 3 is 18. So in this case, we matched it up perfect. I'm going to subtract that, and we have no remainder. Now, if we wanted to write this polynomial division like we did here, we would have x squared plus 9x plus 18 divided by x plus 3, and that just equals x plus 6. So the dividend is the polynomial that's getting divided. The divisor is the thing that we're using to divide here down at the bottom. The result, or what we're calling our answer usually, is called the quotient here. Our remainder is here, and it didn't get out of the divisor, so it's still over the divisor here. Example 3, divide and evaluate the dividend at the root of the divisor. First, we'll worry about the dividing part here. What times x gives me x cubed? I'm only looking at the first term here. I don't care what's happening over here. So we need an x squared. So x squared times x is x cubed. And x squared times minus 3 is minus 3. x squared. And we're going to subtract this off and find out what's left. So we got x cubed minus x cubed is 0. That's perfect. That's what we needed to happen. 2x squared minus 3x squared, so that's 2x squared plus 3x squared is 5x squared. Bring down the next piece here, minus 5x. Okay, now we're looking at the first term here. So what times x gives me 5x squared? Well, that would be 5x. So we put a 5x here, then multiply by both terms in this binomial here, this binomial divisor. So 5x squared minus 15x. And we're going to subtract this away. So the first part disappears, and then we have negative 5x minus 15x. So that's negative 5x plus 15x. So that would be 10x. We bring down the minus 6 here. And what times x gives me 10x? And that would be 10. So we write that there. Multiply by both terms in this binomial divisor. So 10x minus 30. And put brackets around here and subtract. First part disappears. That's perfect. And then we get minus 6 plus 30. So that would be 24. So our remainder in this case is 24. We can write this as an expression here. So we got x cubed plus 2x squared minus 5x minus 6 divided by x minus 3. And that will equal x squared plus 5x plus 10 plus 24 over x minus 3. Now we want to evaluate the dividend at the root of the divisor. So this is the divisor right here, and the root of it will just always be the opposite. It will be, we see minus 3 here, so the root will be plus 3. Root of divisor. Now you can set that divisor equal to 0 and solve this, but it will always be the opposite. So we need to put 3 into this polynomial right here. And why are we doing that? Just to check out something, just to notice a pattern. And that's what the question said to do. Okay, so there we got 3 in there. And we got 27, and then 2 times 9, 18, then minus 15, and minus 6. There we go. So then we got 45 minus 21, and that is 24. So 24, that's an interesting number there, and hopefully it looks familiar because we just saw it. Here. Let's try another question and see what happens. So we got example 4, same thing, divide and evaluate again. So let's divide. We've got what times x equals x cubed. So that will be x squared. Multiply by this binomial. So x cubed plus 3x squared. I'm going to subtract this off. So x cubed minus x cubed is 0. And 2 minus 3, negative 1x squared. Bring down the next one, minus 5x. All right, what times x gives me negative x squared? So we need a negative x here, and then multiply by this binomial. So negative x squared and minus 3x. And then bracket, bracket, minus. And this first term cancels out, and then this one minus 5x minus minus. So minus 5x plus 3x. That'll be minus 2x. Bring down the minus 6. And last step, what times x is negative 2x? So we just need a negative 2 here. Negative 2 times x. Negative 2x, and negative 2 times 3 is negative 6, and looks like it worked out perfectly this time because our remainder is 0. And we can write our division equation like this. So x cubed plus 2x squared minus 5x minus 6 divided by x plus 3. And in this case, it just equals x squared minus x minus 2. Now let's find the root of the divisor again and evaluate that polynomial at that root. So this time the root is minus 3 because it's just the opposite of what we're seeing here in the divisor. So root of divisor is minus 3, just so you know where this minus 3 is coming from. And we're plugging in here, so minus 3 cubed plus 2 times minus 3 squared minus 5 times minus 3 minus 6. Then we've got minus 3 cubed, so that's minus 27. And this one is plus 18. And this one is plus 15. And this one is minus 6. So it looks like the positive numbers here, they add up to 33, and the negative numbers, they add up to negative 33. So this equals 0. And so we can see that this number right here is the remainder. So keep that in mind. That's going to be a great quick way to find the remainder. Example 5, same thing, divide and evaluate. Pause the video and see if you can do this one on your own, and then check if you got it right. All right, hopefully you finished that on your own, and let's go through it together. So we've got x squared here, and when we multiply we get this. We're going to subtract, and this is going to be 4x squared. Bring down the next term. Look at this. What do we need to cancel this out? We're going to need a 4x. Multiply that in, 4x squared minus 8x. We got this first term canceling, and this term will be 3x because 8x minus 5x. Bring down the last term here, and we're going to need a 3 here. So 3 times x is 3x, and 3 times negative 2 is negative 6. And it looks like this one worked out perfectly as well. So we got a remainder of 0. We can write this as a division equation. So there's our original fraction. This line means divided by, right? And this just equals this quadratic. Now another thing to note in these is that we had a cubic. We had a degree 3. And we divided off 1x, or x to the power of 1 here, 1 degree of x. And that actually leaves us with an x squared. All right, let's find the root of the divisor. And in this case, that would be 2, because that's the opposite of what we're seeing here, root of the divisor. And we're going to plug that into here and make sure it does in fact give us our remainder. So 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. And here we've got 8 plus 8 minus 10 minus 6. And so that's 16 minus 16. So that does in fact equal 0, and that does match our remainder. So that works out perfect. Now let's talk about synthetic division. There's a lot of unnecessary stuff going on when we're using long division and dividing by just a basic binomial like this. So every time we're just ignoring these x's. So we can actually break it down like this and remove all the x's, remove all the extra stuff, and do the division much quicker. And that's what we call synthetic division. So these are the steps here. Let's go through them. The first one, bring down the number in the binomial as you see it. take the coefficients in order without missing any positions. So here we got the -1, and we put that right here. The x doesn't matter because it's always going to be x, so it doesn't matter. This one, put the coefficients. So 1, 2, -5, -6, 1, 2, -5, -6. So those match up right there. And then we do this kind of L shape. It's kind of like the upside down division sign for this part here. Next, bring down the first coefficient, record it below. And that's because for the first part, what times x gives me this number right here. So whatever this number is, that's my first part of my answer. And it will always be that. And so for the first part, we can just take this number and bring it down, and there's the first part of my answer. Now the next part is, remember what was happening before. We would take this number that we found first, and we would multiply it by this. Okay, this -1. So that's what we're going to do in the next step. Multiply that coefficient with the number you are dividing by. Put the result under the next coefficient. So we do the -1, that's talking about this -1 right here, and multiply it by this 1 right here, the answer that we found, and we get -1. And then we're going to have 2 minus -1. And that's like what we were doing here before in long division. We would end up subtracting these two here. Then we get 3 here, and we repeat the process till we're done. So 3 times -1 is -3, and then subtract these, get -2, and then multiply by -1 and get 2, and subtract these and get -8. And so there's our answer there. Now, how do we find our answer? These numbers here will give us our answer. Now, when looking back at the question, we had an x cubed and we're dividing off an x, or we're dividing off 1 degree of x. So in our answer, we're going to have x squared, and this represents how many x squareds we have. So we have 1 x squared. In the next part here, we have 3 x's, and in this last part here, we have just -2 as a number. X to the power of 0, but we don't need that. This right here will always be the remainder. Now let's go back and look at the previous examples. So example 3, and let's do this question with synthetic division. So we build our box here, or our upside down division sign. We take this right here, -3. We're subtracting, and then we put the coefficients in the order. So 1, and then 2, and then -5, and -6. Now the first step is just bring down this 1 and put it there. The next part is -3 times 1, so we're multiplying these, and you put the answer here, -3. Now we go 2 minus 3, so that would be 2 plus 3 is 5. And we do the same thing, -3 times 5, and we put the answer here, so -15. And you can see that we're going to have to do -5 minus -15, and that's this step right here, -5 minus -15. So we did that step, but this breaks out just the important stuff. So we can just look at the numbers. All right, this equals 10, and then we do our -3 times 10 is -30. We got -6 minus 30, so that's -6 plus 30, and that would give us our 24. Now let's read our answer. We had a cubic, so we're dividing off 1 degree, so we're going to be left with squared. So squared, x squared, 1x squared, plus 5x, plus 10, and our remainder of 24. And you can see that we got the same answer as we did before, but a lot quicker. Okay, now there is a slight issue here, and that is all these minuses. And in my experience, students tend to make a lot of mistakes when doing that. So there is another method, and all it is changing this here and this. And think of it like a reflection. We're going to multiply both of those by -1. Okay? And then we can add instead, and adding is usually a lot easier, and students make less mistakes. So we do the same steps. In setup, we're going to use the 0 of this instead. So this is x minus 1. We're going to use the 0. That's 1. Or you can just memorize that it's always the opposite of what you see here. Then we're going to put this plus sign here so everybody knows that we're doing this alternate method. Then we bring down the first 1 here. We multiply 1 times 1, put it here, and then we add. And then we multiply, and then we add. And then we multiply, and then we add. And so this here would be our answer, and hopefully it's a lot less likely that we'd make a mistake. So we had an x cubed here. We divided off 1 power or 1 degree of x, so we'd be left with an x squared in our answer. So x squared plus 3x minus 2, and this right here is always the remainder. So let's go back and do the other two using this method of synthetic division, and this is the one that I'm going to use most often because I find students make less mistakes while they use it. All right, here's our example 4. So let's build our upside down box here. Now here we don't put plus 3, we put the root of this one here, so minus 3. And then we're putting a plus sign here just to let everyone know that we're using this alternate method. Then we put the coefficients from this polynomial here, so 1, 2, minus 5, minus 6. Then first step, bring down that 1 and multiply. Put it here. And then add. And then multiply. And then add. And then multiply. And then add. And we're done. And it was a lot quicker than this. And now we can read our answer off here. So we had x cubed. We're going down a degree to x squared. And we get the same answer, just a lot quicker. Let's try the next one. Let's build our upside down division sign. 1, 2, -5, -6. We put the root of this divisor. That would be 2. Put a plus sign here. Now we're ready to go. Bring down the 1, multiply these two, and add these two. Multiply these two, and add these two. And multiply these two, and then add these up, and interpret the answer. X squared plus 4x plus 3, and that's what we got before. Example 6. Divide, and we haven't divided a quartic yet, so this one's a bit longer. And then we'll try this out here. Evaluate the dividend at the root of the divisor. Let's make our synthetic division here. We'll put the 0 of this divisor, so that would be 2. And we'll put a plus sign here. And if you're confident, you can pause the video and do this question, and then restart the video when you're done. Check to see if you got it right. All right, let's put in the coefficients in order. So 1, 3, minus 2, 1, minus 12. And the first step, bring down the 1, and then multiply, and then add it, and multiply, and add, and multiply, and add, and multiply, and add, and then we're done, and we can interpret the answer. So in this question here, we've got x cubed. So this was degree 4, and we divided off 1 degree, so now we're at x cubed. So we got 1x cubed, and then the next part here, 5x squared, and we just keep going down. lowering this exponent by 1 each time. 8x plus 17, and this is our remainder here, so we can write it as 22 over x minus 2. Now let's try that, evaluating the dividend at the root of the divisor. So the root of the divisor is 2, and we used it here. So root of divisor. And let's put that in here. So we've got 2 to the power 4 plus 3, 2 cubed minus 2 times 2 squared plus 2 minus 12. And then we just need to evaluate this. So we've got 16 and then 24 and minus 8 plus 2 minus 12. And we just need to add this up here, and it looks like 42 minus 12 is 30, minus 8 is 22. And that's perfect. Example 7. Can you still use synthetic division if the leading coefficient of the divisor is not 1, like in this example here? And the answer is yes. But you might not want to do it that way. You might want to just revert to long division. Now this will work based on this fact here. If we have a nice easy 12 divided by 6, well, that equals 2. If we could factor the divisor though, so 12 divided by 2 times 3, we can actually divide by one of the factors first. So 12 divided by 2 is 6, and then divide by the other factor of the divisor. So 6 divided by 3 is 2. And the order doesn't matter. So if we were to do it the other way, 12 divided by the 3 factor first would be 4, and then 4 divided by the other factor that we hadn't used yet, 4 divided by 2, and that is also 2. And so that's a trick we can use with this. If we factor the divisor and we factor out a 2, we're going to get 2 out there, and then we're going to get x minus 1/2. And then we can just divide by this binomial first, and then divide by the 2 after. So if we had a 2 here instead, and we factored out a 2, then we would be left with something very nice that we could deal with. We'll just divide by the binomial first, and then once we get our answer, we will divide by the 2. But this question is not that nice. We've got a fraction here no matter what we do. So let's do the division and see what we're going to be left with. We've got a 1 and a 5 and a minus 3. We put the root here and then a plus sign. And let's bring down the 1 and multiply. And add these up. And you could do decimals or fractions, but I'll just write it as a fraction here. Next, multiply this, so 11 over 4. And that's negative 12 over 4 plus 11 over 4, so that's negative 1 over 12. And then we can interpret our answer here, so this will be 1x plus 11 over 2. And this would be minus the 1/12 is our remainder, and that's still over the divisor. Now this part here, we only divided by the binomial. We didn't divide by 2 yet, so that's what we'd have to do here, is divide by that last last factor that we didn't divide by yet. And so we get x over 2 plus 11 over 4, and then minus this remainder term here. We could clean that up a bit, but this is just to show you what we'd have to do here. Not very nice. Now, if you're fairly confident with dividing, you can try this question. Divide p of x equals x cubed minus 27 by x minus 3. So pause the video and give it a try, because there's something really important here that we need to remember. So hopefully you got it right. Let's check it out. Let's do synthetic division with this. Now, long division is a little bit more forgiving with this, but synthetic does not forgive you at all. You'll get the question wrong if you do not put placeholders here. So we have 1x cubed, and then how many x squareds do we have? We have 0, so we need to put a 0 there. And then how many x's do we have? 0 as well. And finally we get to the numbers minus 27. So let's give this one a try. The root of this divisor is 3, and we're doing plus. Bring down the 1, and multiply, and add, and multiply, and add, and multiply, and add. And we got a remainder of 0. Let's write down our answer here. We had a cubic, we divided off 1 degree, so we're going to be left with x squared plus 3x plus 9. So what happens when you evaluate the dividend at the root of the divisor? You get the remainder. And this is actually called the remainder theorem. We're going to make further use of this in future sections, but it's the fastest way to get the remainder, and that's going to be important later on. So remember that. Here's some questions to try. See if you know what you're doing.